This is AQA A-level chemistry, and we're at the end of the organic section now with the topic organic analysis. This is video number 1. In this, we're going to look at some of the common tests that are used to identify different chemicals. It's also an incredibly synoptic topic. It's going to have links to lots of other different chapters that you will be needing to review as part of your overall learning. As always, I'm going to recommend you stop the video, have a go at the activities, and then you get to see how you're doing. So let's jump straight in and let's take a look at the test for alkenes. What's the test and what would we see? And for this one of the more commonly known ones, people remember this very often from GCSE, you are going to add bromine water and the bromine water will decolorize in the presence of a double bond. Now, if we want to be more specific, the brown bromine water goes colourless. Remember, it's colourless, not clear. And also remember that this links to the topic on haloalkanes, where you actually carry this reaction out mechanistically with Br2 acting as an electrophile. Okay, next one, test for haloalkanes, which in a sense is the test for halide ions. So for this one, again, we're going back to GCSE. We are going to add HNO3, nitric acid. That's going to prevent other precipitates forming. Specifically, it removes hydroxide ions because silver hydroxide could be a problematic extra precipitate. And then we are going to add the silver nitrate. And in this, we have got 3 types of ion that could be observed, Cl-, Br- and I-. And you have got to remember that we would have a white precipitate with chloride, a cream precipitate with bromide, and a yellow precipitate with iodide. But we also need to consider that this comes with its own problems because it might be difficult to differentiate between white and cream, between cream and yellow. So we have an extra step. And we can add dilute ammonia to the precipitates that are formed. And if necessary, we go on to add concentrated ammonia. And the observations that we make are as follows. In the case of chloride ions, the white precipitate will redissolve when we add dilute ammonia. The other two, nothing will happen. So we can go ahead and we can add concentrated ammonia. If we add concentrated ammonia, the cream precipitate due to bromide ions will redissolve. But the iodide ions, the precipitate formed does not redissolve. So we've got a really good, clear 2-step process there to conclusively determine whether we have chloride, bromide, or iodide present. Next one, let's take a look at the test for alcohols. And this is an interesting one because he may not have looked at it in the context of testing for alcohols, but we have learnt about the oxidation of alcohols. So to do it, we're going to add potassium dichromate 6, acidified, absolutely vital. I've written down here H plus and Cr2O7 2- also works, and you could have done this as K2 Cr2O7 and H plus. And then what we do is heat it gently. If we have got a primary or a secondary alcohol, the colour change that we get is orange solution to green solution. This test does not work for a tertiary alcohol. There's no visible change because we know that what's actually happening here from the alcohols topic is the primary alcohol is oxidized to an aldehyde, the secondary alcohol is oxidized to a ketone, the tertiary alcohol does not get oxidized at all. That leads quite neatly to the test for aldehydes. Have a go at this one. And again, there are 2 options here. We're essentially discriminating between aldehydes and ketones. We could use Tollens, which is where we add NH3 and AgNO3 and we warm it. And if we do that, the aldehyde will form a silver mirror on the inner surface of the test tube. But with a ketone, there will be no visible change. Alternatively, we could do phalings where we add phalings 1 and phalings 2. That's essentially copper 2 solution and sodium hydroxide, and we warm it. And with this one, we get, again, a positive test result for the aldehyde. A blue solution will give rise to a brick red precipitate. It's very familiar to biologists because it's the same experiment that you do to test for reducing sugars. In biology, we call it Benedict's solution. And then the ketone, once again, there's no visible change. Now let's have a go at the test for carboxylic acids. This sometimes causes a little bit of confusion, but when we're saying test for carboxylic acids, we can think generally about a test we can do on all acids. And a good one to do is to add a metal carbonate. In this case, I'm adding sodium carbonate. And what we will see if we add a metal carbonate to an acid, well, it makes three things. It makes a salt, it makes water, and it makes carbon dioxide. Carbon dioxide means we will see effervescence. But we can go further than that. We can bubble the gas that's produced through lime water. And to prove that it's carbon dioxide, that would go cloudy. One or two questions to finish off. What deduction might we make about a compound that's soluble in water? And what might we deduce about an organic compound, whether when it's a solid, a liquid, or a gas at room temperature? Well, taking each of these questions in turn, the soluble in water tells us fairly conclusively that it's ionic. Ionic compounds are soluble in water. And when we're looking at whether something's a solid, a liquid, or a gas, we're going right back to the alkanes topic and back to work that you did in GCSE. Because we know that increasing chain length increases boiling point, and therefore we are going to see that the chain length will be longer on things that are solid and shorter on things that are a gas. That takes us to the end of this video. Thank you for listening and goodbye.